What's going on, guys? Mr. Rouge again, and this time we're talking about passive cell transport. This is movement without energy, movement without effort. So if we look at these two pictures, we have a lazy cat, and then we have our athlete sprinting. This guy right here is using lots and lots of energy. What we're talking about today is not using any energy. It is passive. It's being very, very docile, like this lazy cat. Okay? So everything we talk about today does not require work, does not require effort, or any input. It just happens on its own, okay? And later on, we're going to talk about this molecule right here, ATP, and just a heads up, we're not going to use it today. Okay, so before we get into it, let's go over some key vocab. First is passive cell transport, or passive transport. This is the movement without energy. Next, we have diffusion. Diffusion is when molecules move from a high concentration to a low concentration. Okay? Diffusion moves from high to low. A concentration gradient is when there is a difference in molecule concentration. When there is a difference. And lastly, equilibrium is when there's an equal amount of molecules being concentrated. Go ahead and put this on pause. Take a quick note of all of these things. And I'm going to show you some examples to clarify what all these words actually mean, okay? So here we go. Diffusion. Again, diffusion always moves from high concentration to low concentration. All right, so here's an example. Let's say if I spray some aerosol or some Febreze in a corner, sprayed some Febreze in a corner, there's a high concentration in the corner. Where are these bad boys going to go? Where are all of these air molecules going to go? They're going to go to low concentration, okay? And this process of moving from high to low, this process is called diffusion. So I would say these molecules are diffusing. Now, if I take a snapshot right now, I would say this is an example of a concentration gradient. What that means, concentration is referring to the amount of molecules, and gradient actually means like grades, different levels, okay? So there's different amounts or different levels of those molecules. In short, there's a difference, okay? So what's going to happen is these molecules are going to keep diffusing throughout the entire room until we hit equilibrium. Equilibrium is when there is an equal amount of those molecules distributed evenly, okay? Equilibrium is the exact opposite of a concentration gradient. So you can only have one or the other. Notice how there's not an equal amount of molecules. There's none over here and there's a lot over here. That's a concentration gradient. Equilibrium, there's an equal amount distributed across the whole space. Okay? So why is passive transport, why doesn't it require energy? Because you're going with the flow. So if you look at these, Black Friday shoppers, trying to get their sales after Thanksgiving, would it be easier to go with the flow into the building, or would it be easier going against the crowd? It would be easier going with, because if you're going against, it's going to require a lot of energy, okay? So for this example, there's a high concentration of people here, there's a low concentration of people in the store, and they're moving from high to low concentration, okay? So if you ever get confused on that, just think Black Friday sales, okay? It's easier to go with the flow. Okay, so go ahead and sketch this little this diagram in your notes. You should be able to tell me these two pictures right here are examples of a concentration gradient because there's a different amount of molecules. This image right here is an example of equilibrium because there's an equal amount distributed across the space. And this process is diffusion, okay? And diffusion, molecules move from high to low, okay? So make sure you guys get this in your notes. Okay, so a few more keywords that we need to go over for this next part. We have osmosis. Osmosis is diffusion of water, okay? Specifically, diffusion of water molecules across the cell membrane. So water is going to go in or out of your cell. A hypertonic solution is when there is a higher concentration of solutes. Solutes, think molecules. There's a higher concentration of molecules in a solution than inside the cell. Hypotonic is when there is a low concentration of solutes or molecules in a solution. And iso means the same. An isotonic solution is when there's an equal concentration of solutes in a solution. All right. So go ahead and take note of this, and let me go ahead and show you guys some examples of these words in action. Oh, also go ahead and jot this down, and don't forget this: salt sucks. And I'll show you guys what this means in just one moment. Okay, so osmosis, again, the diffusion of water molecules across a cell membrane. Okay, diffusion of water across a cell membrane. So let's say this is the cell membrane of our cell. We have water on the inside, we have water on the outside, and since water is a very small molecule, it can easily diffuse across that membrane, no problem, okay, because it's so small. It's only 3 atoms big, okay? But now, what about what I said, salt sucks? A solute is anything that can dissolve in water, okay? Salt is a solute. Salt can dissolve in water. So if I have a lot of salt or solutes on one side relative to the other side, relative means comparing, this side is a hypertonic solution. This side is hypertonic because there's more solutes on this side. This side has less solutes. So this is a hypotonic solution. Hypo means low. Okay? So watch what happens. Remember I said salt sucks? These solutes, or this salt, is actually going to attract more water molecules across the cell membrane. And this side is actually going to have more water. Okay? Now, let's switch it. This one still has 1 salt cube, but this one has 3. 2 and 3. Now, this side is a hypertonic solution because there's more solutes than this side, and this one is a hypotonic solution. So what's going to happen? Well, remember, salt sucks. So that water is going to be attracted to the salt, and it's going to move across the cell membrane. Remember, that's called osmosis. So this process right here, the water actually moving across, that is osmosis. And why is it moving across in that direction? Because there is a hypertonic solution. Okay? Now, what if there's an equal number of solutes on each side? This is an isotonic solution. Iso is referring to the same or stable, okay? Same amount. So what's going to happen is we're still going to have water molecules going across, but it equals the exact same. Okay, so there's no net change. Okay, let me show you guys a better animation that'll give you a better idea in your head of how this affects a cell. Let's say this is our cell. Inside of this cell, we have, 1, 2, 3 salt molecules. Outside, we have several. So this right here is a hypertonic solution. Hypertonic, okay? Remember, salt sucks. So water is going to be attracted out of that cell. And now what's going to happen to that cell when water leaves? That cell is actually going to shrink in size. Okay? And what's going to happen is, why is that happening? Well, it's trying to reach equilibrium. The environment's trying to reach equilibrium, so there's an equal concentration of salt on both inside and outside the cell. So that's why the cell is actually going to shrink because water is going to leave. Okay? And you guys may have seen this before. If you've ever put salt on a snail or a slug, you'll see that they start, it kills them, okay? And you see that they start to get wet. They start to get wetter because it's actually drawing water out of all of their cells. And that snail or slug actually dehydrates to death because that water is leaving their body, okay? Let's look at the exact opposite. let's say there's more solutes inside of a cell and less outside. I should clarify, when I use this word hyper and hypotonic, I'm always referring to the solution around the cell, okay? So this is a hypotonic solution because this is a solution around the cell. There's less solutes. Now, what's going to happen to this cell? Remember, salt sucks. So the salt is going to suck water into the cell, and that's going to cause the cell to actually swell up, okay? And why is that happening? Because the environment's trying to reach equilibrium. So it's trying to have the same concentration outside and inside, okay? Remember, a cell in a hypotonic solution is going to swell up because water is going to enter the cell, okay? Oops. Okay. Now, if we're in an isotonic solution, okay, and a lot of times students call me out right now, they say, Aruj, check it out, dude. There's more solutes outside than there is inside. And I'll say you are correct, but the concentration is the same. There's the same ratio of solutes per amount of water. Okay, so the ratio is the same. This is a smaller amount of water. This is a larger amount of water. Okay, so in an isotonic solution, we're going to have water enter and leave the cell at the same time, but there's going to be no net change. It's going to equal the same amount. Okay. So to maintain homeostasis, your cells want to be in an isotonic solution. Okay. Go ahead and give this a quick sketch in your notes, and I want you guys to identify this. Hypotonic solution, hypertonic, and isotonic. And remember, this word hypotonic is always referring to the solution around the cell. Hypertonic is referring to the solution around the cell. Okay? We're not talking about the solutes inside. Isotonic, we're referring to outside the cell, the solution outside. Okay? And the hypotonic, more water is going to go in, and that cell is going to swell up. Hypertonic, more water is going to leave. That cell is going to shrink. In an isotonic solution, there's no net change. The same amount that enters is the same that leaves. Okay? So why is this important? Well, if anybody's ever been to the hospital or seen an IV bag, it's not pure water that they're putting into someone's veins. It's 0.9% sodium chloride or 0.9% salt. Why is that? Because if they were to put in distilled water which has no solutes, they just put your cells in a hypotonic solution. Your cells are going to swell up, and they might even pop. They might pop, okay? If they put more than 0.9% sodium chloride or 0.9% salt, they just put your cells in a hypertonic solution. So then all of your blood cells are going to shrivel up. So it has to be 0.9% because that matches your body. Our bodies, the amount of sodium chloride in our body is 0.9%. So they're giving your IV an isotonic solution. So your red blood cells stay the same. Okay? And they're not affected. All right, so a quick recap. Diffusion. Diffusion is the movement of molecules from high to low concentration. A concentration gradient is when there is a difference in the concentration. So this shows a concentration gradient, and this shows a concentration gradient. Equilibrium is when there's an equal amount, okay, in a solution. Osmosis is the diffusion of water, but across the cell membrane. In a hypertonic solution, there's more solutes outside of the cell. In a hypotonic solution, there's less solutes outside the cell. In an isotonic solution, there is an equal amount or an equal concentration of solutes outside the cell. In the hypertonic solution, this cell is going to shrivel. Hypotonic solution, more water is going to go inside. This cell is going to swell. Isotonic, it's going to stay the same. That's it for today, guys, and I'll catch you all next time. Peace.